Hello, I am Mrs. Leonard, and this is the video for the graphing output page for question number 2 that we did in class on Friday, September 15th. So you should already have your notes completed on graphing for your input page on page 3. And for this video, you probably already watched the video for question number 1. We're doing question number 2 today. You're going to need some tape, a calculator, and a pencil for this. Okay. So you should already have your question number 1 finished. This is an easier question. And then some of you wanted to work on question number 2 for homework. And so for question number 2, it looks like this. It should already be taped into your notebook on page 2, like this, okay? And just like we did for the question number 1, we're going to really read through the question first. Then we're going to follow our steps for creating a scale. And then we're going to graph the data. So we're going to do exactly like the same thing that we did for question number 1, we're going to do today for question number 2. So question number 2 says, the table below shows the area in million square kilometers of the Arctic Ocean covered by ice from June through November. The average area covered by ice from 1979 to 2000 from June to November is compared to the area covered by ice in 2005 for the same time period. So here's my data table. And then the question asks, or says, it's not really a question, it's a direction. Use the information in the data table to construct a line graph. So once again, they're telling me what kind of graph to create. So that's an important piece you want to annotate. On the grid below, plot the data for the area covered by ice in 2005. So this is another piece of information that's important because it's telling me that I should use this data and that I do not have to use this data. For each month shown on the data table, and connect the points with a line. This is another piece of information that is important. You want to make sure that you connect them with a line. The average area covered by ice for 1979 to 2000 has been plotted and labeled on the grid. So here's the line already for this data that I crossed out. So they did that already for us. So now you'll notice that this graph does not have a scale on the y-axis, but it does have one down here for the x-axis. This is a line graph because this is time, and we could put numbers here, right? So this is, you could have actually called this 605 because this is June 2005, 7, 8, 9, 10. So because these are months and they look like words, you might think to yourself, oh, I have to create a bar graph. But we're creating a line graph because these could also be numbers. Anytime it's time, then it's going to be a line graph because time can be represented by numbers. Okay. So we need to create a scale. Look back at your notes and see what is the first step that you have to take in order to create this scale. All right, so if you said count the number of lines, you were correct. So pause the video and count the number of lines on your y-axis right here. And then when you come back, you can check and see if you were right. Okay, so hopefully you figured out that there were 41 lines. And just like before, I'm going to show all of my work here so that way if I make an error, I can go back and know what exactly I did wrong. Okay, so I've got 41 lines here. And now I want to go and see what is my next step. Go back to your notes and see what is my next step. So you should have seen that you have to subtract your highest versus your lowest value. So my highest value in my data set here looks like it is 11.3. That's my highest. My lowest value is 5.6. When I subtract those numbers, I get 5.7. 10 minus 5 is 5.7. So if I have 5.7, what does that number mean? Am I done? Look back at my notes and see. Aha, I see that I need to divide that number by the number of lines, which was 41. Now in class, this is where students struggled. Instead, people were dividing 41 by 5.7. Nope, it's 5.7 divided by 41. Okay, sometimes in our science, you're going to divide a small number by a big number. So on my calculator, I have an engineering calculator, which is probably different from yours. I'm going to say 5.7, and I'm going to divide it by 41. So when I do that, I get 0.1, and I can round this 14. So what that means to me, if you're not good with decimals, think about this in terms of money. I think of this as like 14 cents, right? And if a dollar would be 1.0, that would be $1, right? So that if you get confused with decimals, think about it in terms of money, and that will help you a little bit, okay? So this is the number then that's going to tell me how much I go up by. Now again, you want to think to yourself, does it make sense for me to go up by 0.14? Probably not. So this is where we round up, okay? Now I could round up to 0.15, but again, does it make sense to go up by 0.15 each time? Probably not. Okay, we've got these big bold lines here, okay? And so my lowest value is 5.6, or you could think about this as 5.60 and 8.50 and 10.50. If you're thinking about money, this might help you. This is $5.60. That's my lowest value. It probably makes sense to make this one down here 5.0 or 5.00, $5. Think about it that way. And then if I go up, the next like most rounded number off would be 20 cents, right? I could round it all the way up so there's a 0 at the end, 0.20. And so if I said this is 5.00, then this next one would be 5.20. And then this next one, think to yourself, or you could even say it out loud if you're doing this video by yourself. So this one would be 5.40. If you're going up by 0.20 or 20 cents each time, think about it in terms of cents, right? If that helps you. And so this would be 0.2, 0.4, 0.6, 0.8, and this would be 6.00. So if you think about this in terms of going up by 0.2s, I think that makes sense with each of these bold lines. So this one would be 5.2, this one is 5.4, this one is 5.6, and this one is 5.8. Now I drew these little lines here because I can't write that small. I'm not going to do that all the way up because that's going to be silly looking. But I am going to label each of these bold lines, and then I can just use this down here as a reminder that, oh yeah, this is 0.2, this one is 0.4, 5.4, so each one is going to be 0.2, 0.4, 0.6, 0.8 all the way up. So if this is 6.0, go ahead and label the rest of your scale. You can pause the video now and do that, and then when you come back, you can see if you did it correctly. Okay, so if you did this correctly, your scale should now be labeled like this. And you don't actually have to go up any higher than 12.0 or 12.00 because the highest value we have is 11.3. So if you did this correctly and you went all the way to the top, you might have 13.00, and then that means you did it correctly. Okay, so good job. So now the last thing is you want to graph your data and then plot the points, connect the points with a line. So when you graph your data, you're going to start with June. June is 11.3. So I'm going to go all the way up to 11. And do you remember what each line is represented here? If this is 11, this one is 11.2, 11.4, and that means 11.3 is exactly halfway in between. Again, if you get confused, here's 11.2 would be 11.20 or $11.20. 11.4 is like $11.40. So halfway in between is $11.30, which is what this number represents. Okay, so if you get confused, again, put a 0 at the end and make it seem like it's money, and that might help you with this. So I'll do another one, and then you can pause the video and come back and see if you did it correctly. You could even pause it now if you wanted to. July is 8.9. So I'm going to go up here. Here's 8.2, 8.4, 8.6, 8.8. And so 8.9 is halfway between 8.8 and 9.0. In August is 6.3. So here's 6.0, 6.2, 6.4. So 6.3 would be halfway between 6.4 and 6.2. September is 5.6. So if this is 5, 5.2, 5.4, 5.6, that ends up being right on the line. October is 8.5. So here's 8. Follow that over to October. There's 8.2, 8.4, 8.6. So 8.5 is in between, halfway in between 8.4 and 8.6. And then finally November is 10.5. There's 10. Follow that over. Here's 10.0, 10.2, 10.4, 10.6. Halfway between 10.4 and 10.6 is 10.5. So that's what your plots should look like. And then when you connect those points with a line, you can start over here. Sometimes I'll start over here and then I'll stop and maybe I'll start it over here again. Notice that I don't have to use a ruler for this, right? You're just making a nice smooth curve. That's what they did for this one. So I'm just kind of following along with what they did, okay? And now you are all finished with your graph. So hopefully that helped you to complete graph or question number 2 for your output page for graphing. And that way you can be all finished with that and ready to start class on Monday morning. If you have any questions, you can come in at lunch, after school, or before school, or you can feel free to email me. And I hope that this helps. Thanks.